So we're interested in how to use data in governance. And so far, we've looked at the sources of data and how to manage data. The third aspect is analyzing the data. And this is called data analytics, or extracting meaning from raw data using specialized computer systems that transform, organize, and model the data to draw conclusions and identify patterns. Data analytics can answer 4 key questions. What happened? Why it happened? What will happen? And how to make it happen. So the first kind of analytics is called Descriptive Analytics. It's the use of data aggregation and data mining to provide insights to answer what has happened. The common methods used are observation, case studies, and surveys. Descriptive analytics rarely attempts to investigate or establish cause and effect relationships. It summarizes past events. It tabulates social metrics such as Facebook likes, tweets, or followers, and reports on general trends like hot travel destinations or news trends. Unlike descriptive analytics, diagnostic analytics tries to answer the question, why it happened. It drills down to find dependencies and to identify patterns. So diagnostic analytics is used to identify anomalies, for discovery, and to determine causal relationships. The third type is predictive analytics. It uses statistical models and forecast techniques to answer the question, what could happen? Predictive analytics provides actionable insights by combining historical data to identify patterns and apply statistical models and algorithms to capture relationships between various datasets. In the private sector, they use predictive analytics to forecast customer behavior and purchasing patterns, identifying trends in sales activities, and demand for inputs for the supply chain operations and inventory. One of the interesting use of predictive analytics is in purchasing. For instance, in auto, which is the second largest retailer online retailer in Europe, its IT system analyzes about 3 billion past transactions and 200 variables, including past sale, searches on websites, and weather information, to predict with 90% accuracy what customers will be buying in the coming week. So Otto's IT system is so reliable and accurate that they've allowed it to purchase supplies or inventory. It allowed it to purchase inventory without human intervention. So essentially, Otto's IT system is the one that decides what will be stocked in the stores in the coming week. The fourth kind of analytics is prescriptive analytics. It answers the question, what action to take? Predictive analytics provides recommendations around optimal actions to achieve business objectives such as customer services, profits, and operational efficiency. Prescriptive analytics use a combination of techniques and tools such as business rules, machine learning, and computational modeling procedures, and apply these to different data sets, including historical and transactional data and real-time data. Companies use prescriptive analytics to optimize production, scheduling, and inventory. Now, analytics is also used in order to facilitate decision-making. So, particularly predictive analytics and prescriptive analytics. At the heart of analytics is algorithms, a set of mathematical instruction or rules that, given to a computer, will help to calculate an answer to a problem. Businesses, including governments, use analytics to make decisions. The idea is that there is less bias if machines, rather than individuals, make decisions. But it turns out that that is not necessarily the case. We now know that there's also what is called algorithmic bias. Algorithmic bias means that human prejudice and partiality are incorporated in the algorithm. Now, again, this is not surprising. Humans write the algorithm, and sometimes their own biases are reflected in it. As a consequence, discrimination is embedded in the model. So why do we have algorithm bias? First, bias occurs when there is poor quality input data. The data may be biased, incomplete, or otherwise of poor quality. Another cause is poorly defined rules. The data used as an input for algorithmic decision may be poorly weighted. A third cause is lack of contextual awareness. The definition of the quality of the training data and the robustness of the rules and weights is often context-specific. So an algorithm that works well within the context for which they were designed might discriminate if rolled out in a different context. Then there's a problem with feedback loops. Algorithms don't operate in a vacuum. Their activity affects the environment from which they extract the data they use as input. A biased algorithm might reinforce its biases in what could be deemed as a self-fulfilling prophecy loop. So, algorithmic bias can lead to two kinds of harm. The first is allocative harm. The second is representational harm. Allocative harm is when the algorithm apportions or withholds certain opportunities or resources based on prejudiced assumptions. So for instance, it has been shown that some bank loan risk assessment algorithm systematically denies loan applications to women. The second type of harm is representational harm. Here, the system reinforced the subordination of some groups along the lines of identity. In representational harm, technology reinforces stereotypes. For instance, in 2015, Google's photo app mistakenly tagged a photo of two black people as gorillas because its algorithm hadn't been trained with enough images of dark-skinned persons.